Okay, guys, so I threw in a couple of factoring by grouping problems. That's what we learned yesterday. I put that into the bell work because it's going to tie into what we're doing today. So let's review this and make sure we all have this and we're comfortable with this. So the big thing about factoring by grouping is it's a dead giveaway. It's the only problem you're ever going to see that has 4 terms. So 1, 2, 3, 4. So that's what tells you you're going to do factoring by grouping right away. The very first step, usually, I mean, you can try to take out the GCF if there is one out of all 4 of them. This one doesn't have one, and if you forget to do it, you can always catch it at the end just by looking at your 2 smaller parentheses. If it has a GCF at the end, pull it out, and that just means it had a GCF to start. This one doesn't have one, though. So the first step, we call it split the middle. So we put 2 sets of parentheses. We don't use the plus sign that's in the middle, because if you were to include that plus sign, it means times now. Now that's a totally different question. So we just treat these like 2 separate problems. We find the GCF of the first one, and then we find the GCF of the second one. What is the GCF of the first one? It's just y. Yeah. So we're going to put a y at the bottom here and a y at the bottom here. I'm just going to show the work to show you where everything's going. So in that first part of my problem, the first half of this problem, when I put that y at the bottom, that's your GCF, and that's what goes in the front. So then I have a parentheses here, and my parentheses is going to contain 2 terms, and each one is just going to have 1 less y, because we took out the y and we put it in front. So this is y, and this is now just plus 7. Then I bring down that plus sign, and then I find the GCF of the second set of parentheses. So in the second set, it looks like it's going to have a GCF of 5 and x. So both of those numbers can be divided by 5, and then they both have x, so the GCF is 5x. So anytime you put that stuff at the bottom, that's your GCF, and GCFs always go in the front. So I have a 5x right here. Then in the parentheses, we show what's left once we divide those terms by 5x. So I have, what do I have? I have y, and then 35x divided by 5x is just plus 7. Are we on the right track? How can you tell? Yeah, our parentheses match. So the blue parentheses match. If the parentheses don't match, that means that you did the GCF wrong. So that's how you can always tell if you're on the right track. So as I was walking around, I noticed that people got to this step and then they just stopped. And that's I mean, I'm okay with that. At this point in the chapter, I'm okay with that because you already did the hard part. The writing of the final answer is the easy part. So if you want to write your final answer, what you do is you take these 2 parentheses. These 2 match exactly. So by definition, we saw yesterday that that's considered a GCF. If they both have it, it's a GCF. And anytime we have a GCF, we pull it out and we write it in the front once. So I put y plus 7 over here in the front. Then I take the stuff that was in the front of each of these sets of parentheses. Oops, I'm going to go ahead and circle the plus also because it goes with it. And we use those 2 terms to create our second set of parentheses. So in this one, we end up with y plus 5x, and that's our answer. If you really wanted to check, you can always FOIL it, and it should give you the original problem again. The second problem, I want to make sure everyone remembered that this is the one that people usually miss on the test because of this minus right here. If I have a minus and I split the middle with the parentheses, that minus causes the sign in the right set of parentheses to change to its opposite. Right now it's a minus, so I'm going to make it into a plus. The reason why we do that is because when you add the parentheses, it's actually not the same problem anymore. So that's why we have to change that sign. Okay, so I'm going to go a little faster on this one. We're going to find the GCF of each parentheses. So this would be 2x. The second one would be 3. So in the first set of parentheses, we have 2x in the front. And then we have x plus 7 again. It's like the last problem almost. I bring down the minus. We put the 3 in the front. Oops. And then the parentheses leaves us with x plus 7. Again, the matching parentheses is the GCF. Pull it out to the front. And then the stuff that was the original GCF of each problem, we put that into its own set of parentheses. So that's our answer. So I wanted to make sure to sort of be very thorough on that, because the next type of problem that I'm going to teach you. So far you should know, let me think, you should know 3 types of problems. You should know how to do a GCF problem. GCFs could look like any problem. They could have 4 terms, 3 terms, 2 terms. Any problem could have a GCF. You should know how to do a simple ABC. You should know how to recognize it. ABC means that it has 3 terms. Simple means A is 1, so the front number is 1. Today we're going to focus on what we call complex ABC. So the complex ABC is the 4th one that we have to know. Now the reason why I had to show you how to do grouping is because the method for doing a complex is actually converting it into a grouping problem. So we're going to almost follow the same process, except the beginning part is going to be just a little bit different. So first of all, it's an ABC problem. It's not simple because there's a 3 in front of this problem. So automatically it's not simple, especially because 3 is not the GCF. If 3 was the GCF, we could have pulled it out and made it into a simple. So these complex ABCs, they have a number in front, and I even listed it right here on the side. They have a number in the front that's not 1, so it's basically any other number besides 1, and that number is also not the GCF. So that number is literally there. It's there to stay. So I'm going to show you the steps. You'll notice in your notes, the first step is already in for you, because that should always be our first step. If you forget to do it, you can always catch it at the end. So I'm going to show you the next step. In a complex ABC, the next step is going to be to multiply the A and the C. So in our problem, the A and the C are these 2. That's A, that's C. We want to multiply these together. So 3 times 8, that's 24. After we multiply that, we're going to use that to list the factors. So if you think about the simple ABC, this is exactly what we did with the simple ABC, except on the simple, we just used the last number. And I mean, technically, we were still doing this on the simple, it's just that the first number was 1. So anytime you multiply a number by 1, it doesn't change it. So that's why we were just using the last number. So we're going to make the list for 24. If you want, you can do it in the calculator the way I showed you yesterday. I'm just going to make the list really quick. So it's 1 and 24, 2 and 12, 3 and 8, 4 and 6. 5 doesn't work. 6 works, but 6 is already there. So once it starts repeating, that's how we know we have the whole list. So after we make the list, this is kind of like the simple ABC stuff. We're going to try to pick the pair that makes B, just like before. So out of that list, which pair is going to make 10? So I'm going to circle that one. Also, just like before, we're going to put the signs to make sure that it works out with both of the numbers. It has to multiply to the positive 24, and it also has to add to the 10. Guys, these problems, when they're all full of plus signs, there's no doubt what the signs are going to be. It's going to be plus, plus. Now, if this was a simple ABC, we would have been done. We would have put x plus 4 and x plus 6. See, but the problem with that is, if you FOIL x plus 4 and x plus 6, you're not going to get a 3x squared out of it. So this is where it differs just a little bit. And this 4th step, it's a little longer. Like, you're going to have to write the whole sentence. It says, what we're going to do is we're going to rewrite this ABC problem, but instead of using that 10x, we're going to replace it with the 2 numbers that we just found, and we're going to attach x's to those. So this is that step where we're converting it into a factor by grouping. Factor by grouping needs 4 parts to it. So we're going to take the middle, and we're going to split it up into 2 parts. Now, I've had students in the past ask me, like, should I put the 4 first or the 6 first? It doesn't matter. It doesn't matter how you do it, because in the end, it all works out to be the same anyways. So here's what we do. We are literally going to replace this 10x with the two numbers there. So I have plus 4, and it needs to add up to 10x, so I need to put an x on it. And then plus 6x. And then we're going to bring down the first term, and then we're going to bring down the last term. So there's our conversion part, and now we just do it exactly how we did the bell work. So what we're doing is we're forcing it to have 4 terms so that we can factor it by grouping. And that's why I was saying, like, it's going to be important you know how to factor by grouping, because there's actually 2 different types of problems you have to do that way. So factor by grouping now. Review. We put the parentheses around each set of 2 terms, not including the plus sign in the center. We take out the GCF. So it looks like my GCF in this problem in the first part is just going to be x. So if I rewrite that, I have x, then I have parentheses 3x plus 4. And I can actually use that as sort of like help to try to make the second set of parentheses, since we already know the second set is going to match that one. So if I'm just thinking like I have a 6x and an 8, what do I have to divide by to get 3x plus 4 out of it? You would just have to divide it by 2. So divide that by 2 and divide that by 2. I'm going to bring down that plus sign. Now I'll put the 2 in front. And then in parentheses, we end up with the 3x plus 4. So again, to write the final answer, we take the 2 matching parentheses, and we just pull them out into the front. They are considered a GCF because they both have it. Then we take the stuff that's in the front, and that's what we use to create the second set of parentheses. So this is x plus 2. And now you can see, if we were to FOIL this out, I got 3x times x. That's going to give me my 3x squared now. If I had done this the way we did simple ABC, it wouldn't have ever given me a 3x, or the 3x squared. So the only new step is this step right here. We are turning the problem from a trinomial into a polynomial with 4 terms. The reason why is because we have to do this by grouping whenever it has that number in the front. So I'm going to show you this a couple more times, and then you're going to have a lot of time today to practice what we've done up to this point. So let me show you this a couple more times. So the next one says 3x squared minus x plus 10. Now looking at that, there's no GCF, so I can't take out a GCF. So that makes it a complex ABC. In complex ABC, we multiply the first times the last. So the A times the C. And that's going to make us, it's going to force us to make a list for negative 30. The list for 30 is 1 times 30, 2 times 15, 3 times 10, 4 doesn't work, 5 works, 5 times 6, and then 6 works, but 6 is already there. So once that list starts repeating, we know we've got the whole list. So what number are we trying to make again? Well, all of these make 30, but the second thing I checked is the middle. This middle number is a 1. So I have to pick the set or the pair of numbers that gets me to 1. And the nice thing is there's only 1. It's 5 and 6. Now, how would the signs go to get us to a negative 1? Yes. Plus 5, negative 6. Did I tell you guys this yesterday? You see this sign right here? That sign always goes on the bigger number when you have your pair. That's how it works. So that sign's a negative, so 6 is bigger, so I put the negative there and the plus there. So that makes it add to negative 1, and it also makes it multiply to negative 30. So what we end up doing with that information now is we use it to replace this term. And since this term has an x, I'm going to attach x's to this. So this is 5x minus 6x. Then I bring down the first term, 3x squared. I bring down the last term, minus 10. And now I've converted it to 4 terms, so now I can do it by grouping. So I do this, first set of parentheses, Second set of parentheses. Uh-oh. Do you guys see it? Yeah. That has a minus in the center. So anytime there's a minus in the center, we have to adjust the problem by making this sign change to the opposite. It was a minus, so I made it a plus. If it was already a plus, I would have made it a minus. Okay, so now I GCF each section. 3 and 5 don't have a GCF other than 1, and that's not going to help us here. Yeah. Well, technically it is, because once I distribute, it turns it negative. And then see, the other thing was, remember how before I put that plus sign, it was a minus 10? This negative, when we distribute it over, is going to turn it back to a minus 10. And that's why we had to change the sign. If that sign, if we had left it as a negative, when I distribute this negative over to it, it would have turned to a positive, and that's not what the problem says. The problem says it has to be a negative. So that's why we only adjust the other one. The first one does not get affected when we put the parentheses. It's only the second one that does. So our GCF to this problem, let's do it in blue, it's just x. So I'm going to put the x in the front. That's going to leave me with 3x plus 5. I'll bring down the minus. Then I GCF the second part. I got a 6x and a 10. Looks like, yeah, they're both even, so it's at least 2. So it's 2 on this one. I put the 2 in the front. And I put the results of those division problems. So it's 3x plus 5. And again, to write the final answer now, we got the matching parentheses. I like putting those first because that's where I usually put GCFs. I put them in front. And then I take the front part here with this, and that creates my second set of parentheses. And I think that's, if I look at the next page, I think it's Big Ideas Math time. I left all the steps there so you can see it. I'll be walking around sort of helping you on this one because I can already tell. Look at this. Oh, this isn't even a complex ABC. See how this one has a 1 right here? That one's not even a complex. It does have a GCF though. So it looks like they're starting to kind of get mixed up a little bit, actually. Maybe I didn't assign the right questions. But that's okay. That's good review. So you guys are going to have, it's barely 8, was it 8:18? So you have over 30 minutes to practice this stuff. And like I said, I'm not going to sit down today. I'm just going to walk around and help you out. So the Chromebooks, no, the tablets are in the back. And if you want, you can use your phones. It's fine too. I think the only one that's going to be a complex ABC is number 10. It's got 3, 11, and 20. You can't take out the 3. Was there a second example? There was another one? Where's mine? Oh, you know what happened? Stupid box. You guys want to see this one? You got it? Be careful because you see how it's 4, 10, and 6? There's a GCF there. So either pull out the 2 first or pull out the 2 at the end. I'm going to write it up here. If you want to see it, you can see it. Let's see, I'll do the GCF at the end. Whatever. You guys are going to be pros at 24. See how many times 24 comes up in these problems? So it's going to be 10. That's that. That's actually not it, yeah. This one, and it's got to be negative and positive. So we're going to use that here. Minus 2x plus 12x. 4 squared. If you're interested in that last example, it's up. I try to color code it so you can see where everything's coming from. Remember, we said in the beginning there's a GCF of 2. If you don't take it out in the beginning, you can always take it out at the end. One of the parentheses will have the 2 in it. So you just take it out and put it in the front. That should be the answer to that example.
Yours has the, this one.
I forgot that.
Again?
Okay, so.
Just have these next to it.
So this still doesn't work.
Let me show you right next to something. What was the middle? Negative what? Okay, 2x squared, and then 24? Okay, so you're not doing it wrong. It's going to give you the right answer in the end, but when you do a complex versus a simple, simple is called simple because it's very short. Like once you get that list and you circle the numbers, that's your answer. In this one, what you could do is you could just take out the x first. So we take this out, and this is x squared minus 2x minus 24. And you already did the list, right? Did you use 6 and 4? So let's pretend we did the whole list over here, blah, blah, blah. You put 4 and 6, and you said that you were going to do negative 6 and plus 4. So at this point, we don't have to do this. We can just go like this. Plus 4 minus 6. There's the answer. See, and that's why it's important to know the difference between simple and complex. Complex will still work. It's just you're going to do a bunch of extra steps, and you'll eventually get to this. But the reason why I didn't have to is because of this right here. It has a 1 in front.
By the way, what's the password?
Password?
Yeah.
Parra math 1 period.
I know, I put period.
Oh, because we're first hour. Did you take out the x in the very first step? Oh, okay, so it's not going to work right if you don't. Because you know how let me see. You know how we split this up into those 2 numbers? I don't think it's supposed to be x squared both times. Let me do it. I don't know. So it was plus 4x squared minus 6x squared. It actually might still work. X third minus 24 x. This one. Yes. So divide by x squared, oh, parentheses. Parentheses, and so that makes this a plus. So x squared in front, and then we put x plus 4. Bring down the minus. This is 6x. So 6x here. 4. So now we have x plus 4. X squared minus 6x. So right here we can take out the x. So it's x plus 4.
That's tight, huh? So the only thing though is like this one always works on all the problems if it's an ABC. Yeah, you can do this one on every problem, even if it was just this x squared minus 2x what is it? Minus 8. You can still do it here. It's just that it's more steps. So for me, I'm lazy. I don't want to do steps. So I always check to see if there's a 1. If I see a 1 there, I'm doing it this way. Yeah. Yeah. Good, what? Yeah. You already signed up, right? Yeah.